AI safety and the Bugmageddon reckoning. The Wall Street Journal this week published the most detailed account yet of Nicholas Carlini's transformation from AI security skeptic to the person Anthropic dispatched to calm the White House. The profile traces how Carlini, a researcher who once called OpenAI unreasonable for suggesting GPT-2 might be too dangerous to release, used Mythos to find 479 bugs in the Linux kernel and a critical vulnerability in Ghost web publishing software, all through what the security community now calls the Carlini loop, a prompt technique that gives Mythos just enough variation to produce different results on each pass through a codebase. Carlini's assessment is blunt. It's pretty clear to me that these current models are better vulnerability researchers than I am. The political dimension is what makes the story combustible. Within days of Fable 5's release, Amazon CEO Andy Jassy called Treasury Secretary Scott Bessent to report that his researchers had found ways around the guardrails. The Trump administration gave Anthropic CEO Dario Amodei a 90-minute ultimatum to pull the model or face a foreign user ban, without initially providing details about the security concern. Commerce Secretary Howard Lutnick delivered the kill shot. When Amodei protested that pulling the model was premature, Lutnick responded, "That's the point." Anthropic shut down all access. The ban covers foreign-born individuals working in the U.S., affecting some of Anthropic's own researchers. Independent analysis later determined Amazon hadn't actually achieved a full jailbreak. They couldn't produce weaponized exploit code. But the damage to the Anthropic-White House relationship was done. Mythos has already found more than 10,000 bugs, and Carlini believes other models will catch up within months. Anthropic is now trying to channel that offensive capability into structured defense. The company released a reference implementation for autonomous vulnerability discovery and remediation. A 7-stage pipeline build, recon, find, verify, dedupe report, patch that runs inside gvisor sandboxes with egress restricted to the Claude API. The design is deliberate. Parallel find agents explore different areas of the codebase based on a recon agent's partition. A separate grader reproduces each crash in a fresh container, and a judge agent deduplicates against previously reported bugs. Anthropic recommends teams get hands-on within days. Day 1 for threat modeling and static scans, Day 2 for the reference pipeline, Week 2 for autonomous scanning at scale. The accompanying blog post, based on partnerships with security teams using Mythos Preview, makes the subtext explicit. If this capability exists, you want it working for you, not just against you. Meanwhile, a Bavarian court is drawing a different line in the sand. A Munich civil court ruled Google liable for hallucinations in its AI-generated search summaries after 2 companies were falsely slandered. Google argued these summaries were functionally equivalent to linking to third-party content, but the judges weren't buying it. Google generates this text, and Google is liable, same as if a human employee wrote it. The ruling distinguishes between search results which Google merely indexes and AI overviews which Google creates. As one commenter put it with characteristic precision, the LLM cannot give direct quotations because it doesn't retain original texts, and it's not legally permitted to copy them. So Google can't dodge responsibility for the distortion that results from regenerating information. Google will appeal, and if it loses, AI search summaries may vanish from German results entirely. The larger signal. Courts are converging on the principle that if you generate the text, you own the liability. Open weight frontier and local AI. JIPU's GLM 5.2 drops as a 753 billion parameter, MIT licensed model trained on 28.5 trillion tokens with a native million token context window. And the local AI community is trying to figure out what to do with it. The architecture is a mixture of experts, activating roughly 40 billion parameters per token, which makes the compute profile more tractable than the headline parameter count suggests. At FP8, you need 8 H200S. At 2-bit dynamic quantization, it fits in 176, 180 GB, within reach of a high-end Mac Studio or a 24 GB GPU paired with enough system RAM. Users who've worked with it via API report it's competitive with Claude Opus 4.8 and considerably more pleasant to talk to than either Opus or GPT 5.5. The real excitement, though, is downstream. The community sees GLM 5.2 as a distillation source. Once people start fine-tuning 8B and 70B architectures on its reasoning traces and synthetic datasets, the daily driver local model should improve substantially. That pattern has played out before with each frontier open weight release. The large model's main contribution isn't running locally itself, but making the smaller models better. The announcement thread confirms the model is live, though the Reddit post was mostly metadata by the time it was captured. For those who can't wait for distillation, there's a different path to competitive local performance. A 2-year project by John O'Hare's team ran 672 isolated LLM sessions, grounded in a synthetic multi-domain research ontology 7,445 OWL classes, and found that a local diffusion Gemma 26B model, running on a single GPU with ontology grounding, scored F10.505 on domain-specific factual recall, beating Bear Claude Opus 4.80.350, Sonnet 4.60.373, and Gemini 3.5 Flash 0.423 without grounding. The caveat is important. Frontier models benefit far more from the same grounding opus with ontology hits 0.770. But for regulated environments where data must stay on-premise, the result demonstrates you can match or exceed ungrounded cloud performance at zero API cost and sub-4-second latency. The ontology is a capability multiplier, and it scales with the base model. At the extreme small end, the Monkasearch benchmark tests models from 0.3B to 3B parameters on a practical task, parsing natural language file searches into structured JSON file type, temporal context, specificity. Across 80 queries, models in the 0.8. 1.5B range significantly outperforms sub-0.5 B models with Q, W, E, N3. 0.8B leading the pack. The benchmark is grounded in a real use case. Natural language file search on low-end hardware, CPU-only inference, which makes it more useful than synthetic evaluations for anyone choosing a tiny model for constrained deployment. Agent-autonomy and sandbox infrastructure. Cursor shipped auto review this week, and the design philosophy is worth unpacking because it addresses a real tension in agent-based development. Ask permission too often, and users stop reading the prompts. Ask too rarely, and agents delete 200 customer records. Cursor's solution is a classifier agent that sits in the execution path and evaluates each tool call in context before it runs. The classifier is itself agentic. It can inspect workspace files with read file, grep, and lister before deciding whether to allow or block an action. When it blocks, it returns an explanation to the parent agent, which can often find a safer path without interrupting the user. The result? Only about 4% of reviewed actions get blocked, and only 7% of total sessions in auto-review mode trigger even a single user interruption. Some enterprise customers previously saw 40% of actions blocked. The key insight is that risk depends on the relationship between the action, the user's request, and the consequence of being wrong, not on the action in isolation. The infrastructure layer beneath those agents is getting interesting too. Paradigm Centaur is a self-hosted agent platform built for teams that want one shared agent instead of many one-off local setups. It's Slack native. Mention the bot. It assigns a Kubernetes sandbox for the thread. The agent inspects code and runs commands in isolation, and progress flows back to the channel. The security model is practical. Each conversation runs in a sandbox with default deny network policy. Agents reach the outside world only through a per-sandbox iron proxy, and raw API keys never enter the sandbox. What makes it interesting beyond yet another agent wrapper is the credential boundary. Sandboxes see only placeholder strings for upstream credentials, and real values are injected by the proxy only on outbound requests to specific bound hosts. Taking the sandbox concept in a different direction, Sandboxd is an open-source engine for AI app builder products. The infrastructure that powers type a prompt, get a live website experiences like Lovable or Bolt, but self-hosted. One Go binary tells Docker what to do, with Traefik handling URLs and SQLite as the database. The clever bit is density. Sandboxes go to sleep when idle, freeing memory and wake on the next HTTP request. So a single server handles dozens of users instead of needing a VM each. It ships with OpenCode and Claude Code CLIs pre-installed in every sandbox. The authors are refreshingly honest about what it is and isn't. If you need 1 or 2 containers for yourself, a shell script is simpler. Sandboxd earns its keep when you're running mini sandboxes for other people. Formal proof swarms and autonomous mathematics. The most conceptually ambitious project in today's batch is unsorry, a distributed swarm of autonomous AI agents that pull open goals from a shared repository, attempt lean 4 proofs, verify them against the kernel, and merge them back into a machine-verified library with no human in the correctness path. The safety argument is elegant. Trust is free because the lean kernel rechecks everything. A proof compiles or it doesn't. A careless or adversarial agent cannot poison the library. The work queue, claims, and coordination are all files in the repo. No queue server, no database, no central judge. Checkout and check-in or get operations plus a local build. The project has moved past proof of concept. 5 mathlib-absent results have been proved, including Nikomakous's theorem, k cubed equals sign k squared, and a forced depth-3 decomposition tree of 13 kernel-verified lemmas for the Platonic Schlafly classification. Dependency reuse is demonstrated. The triangular closed form was proved in under 5 minutes by importing the swarm's own Nikomakous lemma. 3 adversarial red team rounds have been passed. The honest limits are clearly stated. Elementary lemmas prove the loop works, not that the research frontier has moved. The open question is whether the swarm scales and sharpens against genuinely hard targets. The project's gate structure is worth noting. Gate A soundness runs a full lake build and rejects any sorry or admit. Gate B hygiene validates coordination artifacts, but can never admit anything into the library. A parallel effort documented in the agent harness generator worklog demonstrates how external teams can compete on unsorry's leaderboard using their own algorithm stacks. The worklog records a 12-step ADR-driven campaign. Ground truth the queue. Architect a 4-layer tool stack sublinear goal selection. Vector-based lemma reuse. Proof memory with ED 25519 attestation. And a meta-harness wiring layer. Verify the toolchain. Produce kernel-verified proofs and submit via the official AISB claim protocol. A swarm of 40 agents produce 32 independently kernel-verified proofs in roughly 3 minutes. The course correction is instructive. Concurrent agents converged on the same goal and produced duplicate PRs, prompting a switch to sequential submission. The team explicitly committed to controlled, one goal at a time contributions rather than autonomous mass fan-out on a collaborator's repository. Developer tooling and pipeline resilience. As AI agents write more code, understanding the blast radius of changes becomes critical. CodeIndex builds a temporal code knowledge graph, a persistent SQLite store of file dependencies, symbol locations, and Git history-aware impact scores, pointed at any project across 12+ languages, and Git per file blast radius scores direct dependence plus 0.5 transitive dependence, hybrid semantic search over symbols, natural language queries fused with keyword and graph expansion, and historical as queries to see what the dependency graph looked like at any prior commit. The MCP server integration is well designed, 10 tools including Git impact, lookup symbol, semantic search, and temporal impact. So Claude or other MCP clients can check blast radius before modifying high-impact files. The claimed token savings on symbol location task are 90%, which tracks. Replacing a full repo grep with an O1 symbol lookup from a pre-built index is the kind of unglamorous optimization that compounds over hundreds of sessions. On the operational side, a developer demonstrated how to make an LLM pipeline survive a provider outage using a stateful finite state machine, rather than the stateless HTTP retrieves offered by gateway-level tools like LightLM or Bifrost. The key insight: a gateway sees an HTTP request that needs a retry, but it doesn't know the failed call was step 2 of a 3-step credit application pipeline. The FSM approach treats provider failure as a state transition, not an error. The LLM call happens inside a tool step that catches the exception and returns a numeric sentinel, and the FSM branches to a provider switch state. Both retry and hard failure scenarios produce the same trace hash SHA-256 of a Merkle tree over step results, which means you get a cryptographically verifiable receipt of what happened during the fallback. It's a demo, not production code, but the architectural distinction. What state was the pipeline in when the provider failed, versus did this HTTP call succeed, is the right question for anyone running multi-step agent workflows. Rounding out the tooling theme, the Langcraft Flux Deep Dive provides a 10-chapter architectural walkthrough of a multi-source social relevance search engine built as an agent skill. The design uses a skill.md file as the control plane, explicit guardrails and coordination for the host model, source adapters for Reddit, X, YouTube, GitHub, and web search with a BYO credentials model, and weighted reciprocal rank fusion for cross-source ranking with per-author caps and entity-aware clustering. The pattern, one skill, one engine, many sources, very explicit guardrails, is a template worth studying for anyone building production agent skills. Compute frontiers, quantum discovery, and GPU safety. Microsoft unveiled Majorana 2, a next-generation topological quantum chip whose qubits maintain quantum state 1,000 times longer than the first generation, a mean lifetime of 20 seconds, with some instances lasting a full minute. For context, other common approaches measure qubit lifetimes in microseconds. The chip uses a lead superconductor, replacing the original aluminum to shield qubits from cosmic disturbances, a materials change that took years to balance against other trade-offs. Combined with 1 microsecond operations and 1 100mm qubit size, Microsoft now expects a commercially valuable quantum computer by 2029, cutting the original timeline in half. The agentic AI angle is the novel part. Microsoft Discovery agents manage workflows, automate measurements, optimize fabrication, and pinpoint previously unnoticed flaws in the quantum hardware development process. As Chetan Nayak put it, agentic AI has permeated almost everything we do. The agents cut measurement cycle times by orders of magnitude for a task that earlier ML approaches couldn't automate. At a very different layer of the compute stack, NVIDIA Labs released Qtile Rust, a system for writing memory-safe, data race-free GPU kernels in idiomatic Rust. It extends Rust's ownership discipline across the GPU launch boundary. Mutable tensors are partitioned into disjoint pieces before launch. Immutable tensors are shared, and generated launchers preserve ownership while GPU work is in flight. The hash macro embeds a captured Rust AST for each kernel in the host binary and JIT compiles through CUDA-tile IR at runtime. Performance is serious. On NVIDIA B200, Qtile Rust reaches 91% of peak memory bandwidth for element-wise operations and 92% of dense F16 peak for gem, competitive with kubeless. The safety overhead is effectively zero. Safe Rust persistent gem is within 0.3% of the corresponding low-level tile IR variant. The companion grout inference engine built with Hugging Face achieves 171 tokens/s for Qwen34B on RTX 5090. On the training theory side, the stochastic weight averaging SWA paper by Ismailov et al. Offers a technique that remains underappreciated despite its simplicity. Average multiple points along the SGD trajectory with a cyclical or constant learning rate, and the resulting model finds flatter, wider optima that generalize better than standard SGD convergence. The geometric insight is that SGD with a high learning rate traverses the surface of a set of good solutions, and averaging the iterates moves inside that set to a more central point. On ImageNet, SWA achieves 0.9% improvement over pre-trained ResNet and DenseNet models in just 10 extra epochs, with essentially zero computational overhead. For practitioners fine-tuning local models on domain-specific data, SWA is a free lunch that should be standard procedure.
Enterprise AI, Knowledge Debt and the Human Layer. Stuart Wintertier's essay on corporate knowledge debt cuts to a problem that most enterprise AI deployments are trying to ignore. Companies have spent years letting knowledge rot in wikis, dashboards, Slack threads, half-updated docs, and tribal memory. Now they want agents to act on that mess. Google's new open knowledge format. Markdown files, YAML front matter, links, folders. Is almost aggressively boring, and that may be the point. The bottleneck for enterprise agents isn't intelligence, it's context. What does this metric mean? Which table is authoritative? Who owns the process? A folder of Markdown doesn't answer those questions, but it forces the conversation about whether the organization has created anything stable enough for agents to act on. The harder admission: enterprise AI is going to force organizations to clean up the knowledge, process, and accountability debt they've been carrying for decades. On the workforce side, Gauntlet AI is running a 10-week, full-time, in-person AI engineering bootcamp in Austin that's funded by hiring partners rather than students. The curriculum escalates from Claude Code and Cursor basics through RAG implementation, open-source AI agents, client projects, fine-tuning and enterprise constraints, multi-agent legacy modernization, and multimodal AI, culminating in a capstone that deploys an RL-based system. Starting compensation for graduates is reported at $200 K+, with hiring partners including enterprise engineering teams. The model: companies pay to watch engineers build under pressure, then hire based on observed output rather than resumes. Is an interesting signal about where AI engineering talent demand actually sits. GrapheneOS has been fully ported to Android 17 on release day, with official builds coming within 24 hours of Google's announcement. The project tested across Pixel 6 through Pixel 10 Pro Fold and will release for all supported devices simultaneously. The speed is remarkable for a privacy-hardened mobile OS that must maintain its own security patches, sandboxed play compatibility, and hardware-level attestation workarounds on top of the AOSP base. For anyone running local models on mobile or concerned about AI-driven device attestation becoming a gatekeeper for what software is allowed to execute, GrapheneOS remains the strongest counterweight to platform control. Finally, watch my escape. A Hugging Face hackathon entry lets users create 2D escape rooms and have LLMs attempt to solve them using action verbs, forcing models to reason about physical environments rather than generating text. It's a sandbox game running locally, built for the Build Small hackathon, and the community response highlights an underexplored niche, using spatial reasoning puzzles as LLM evaluation tools, where the gameplay of designing the challenge is the product, and the model's attempt to solve it is the entertainment.